Good afternoon, everyone. Thank you for coming here to this dedicated teaching session about arterial spin labeling and its use to measure perfusion. My name is Xavier Golin, I'm the chair of that session, and I just have prepared a few slides, just a few minutes of introduction before leaving the floor to all three brilliant teachers. So I thought I wanted to just give a very general introduction, not stealing the thunder from any one of my dear friends and colleagues who are going to follow me. But really, why would you like to measure perfusion? Well, if all organs rely on blood supply for homeostasis, you could have basically two main reasons why perfusion could be clinically important. And the first is, of course, the one which is very well known, in stroke, is that if you don't have blood, then that would result to ischemia. Now, the other possible use of perfusion is not as a diagnostic of a lack of blood to tissue, but as a secondary event from the fact that a part of the tissue, and the brain in this case, will show because it doesn't work very well. In a way, if you have a default in energy metabolism, such as the case in dementia or Alzheimer's disease, like here, well, this low metabolism will be reflected by a low perfusion. So these are two very different. In one case, you have a cause, in the other, the consequence of perfusion. And arterial spin labeling seems to be an interesting method to measure that. Before going to arterial spin labeling, and I'm not going to introduce it because I will leave it to Matthias, perfusion imaging as such, just to introduce a few concepts, I think this is going to be accepted among the people who are going to talk this afternoon. Perfusion is, by definition, the delivery of nutrients such as oxygen, glucose, or anything by the vascular system to the tissue, so it's different from angiography or from the measurement of what is inside the vessel. In physiological terms, perfusion is a physiological term. It comes from people who are studying whole organs physiology. It is a rate. As a physicist, a rate is measured at 1 over time or 1 over second or minute, whatever. So it is a rate. So how much per minute, how much per second. Typically, for historical reason, the measurement has been given as the amount of oxygen delivered to the brain per unit of time divided by the weight of the brain. So the unit will therefore be in milliliter per minute. That's how much bulk perfusion comes to the tissue divided by a certain volume of that tissue. So it's milliliter per minute per 100 gram of tissue. Finally, for the brain, because this is what we're talking about today, the measure of perfusion is called cerebral blood flow. And this is distinct from another method that you've heard of if you've done dynamic susceptibility contrast imaging, which is cerebral blood volume, which is just the quantity of blood, or yet another term of some of the basic terms used in radiology. You've heard of probably the mean transit time, MTT, which is just a ratio of the blood volume over the blood flow. So for now, we are going to talk mostly about the CBF, and for doing so, I'm going to say so. So we can have either the two methods of dynamic susceptibility contrast using gadolinium. We are not talking about that this afternoon. We are talking about this non-invasive intrinsic tracer, arterial spin labeling. And so, who is going to take us through that journey, explaining to us everything you want to know about this method? We'll start by Professor Matthias Günther, who will just go through the very basic steps of the technique, followed by Dr. Jeroen Hendriksen, who will focus on the use of the technique in cerebrovascular diseases. So that's the very first of the two cases I've showed, where the method can be used to detect a lack of delivery of flow to the tissue, while Marion Smith will actually then take you through the second aspect of the technique, where the measurement of perfusion will tell you something about the homeostasis of the disease, of the organ. Finally, and this is also a slide that I could leave up during the discussion part, there are actually active people working in that field, and through EU cost action, you can actually hear about it by going to aslindementia.org. Very soon, in Magnetic Resonance in Medicine, a paper will be published stating what are the main, all the main aspects of this method and what are the parameters we need to use it in the clinics. And if you want to know very much more, I just showed here the recent book that we've been editing. With this, I just have a few more seconds to introduce you Matthias Günther, who's a professor at Fraunhofer Mewis, and he's going to just simply introduce the technique to you. Thank you.